All right, today we are talking about using strip diagrams to solve problems. If you were in my class, we do this almost every single day in our problem solving. But if you're not in my class, here's what we do. All right, Liam has 71 marbles. He gives 56 marbles to his friend. How many marbles does Liam have? Okay, so if you're not in my class, you're about to see how we do our problem solving, not just with strip diagrams, but with just our problems in general. So the first thing we do is we write down important information. So I may say, Liam has 71 marbles. He gave 56 away. And sometimes I'll think about it and say, okay, he gave 56 away, so that means I'm probably subtracting. So that's the first thing we do is we write our important information. The next thing it says, how many marbles does Liam have left? Well, we answer that by writing a sentence. So how many marbles does Liam have left? I would say Liam has blank marbles left. So we write our important information, we write our sentence, and then our next step is to make a strip diagram or any model, but since this video is on strip diagrams, that's how we're going to do it. I use them a lot in my class. All right, so strip diagram, you don't have to, but I traditionally put the total on top. So I think of, do we have a total in this case? I think we do. I think Liam started with 71. So that's going to be our total. He gives 56 away. So that's going to be one of our parts. And then we're looking for how many marbles he has left. So maybe I'll put M for marbles. And we could say something like, if we wanted to write an equation, which in our room we always do, we do important information, we write our sentence, we make our strip diagram, and then we write an equation. So an equation here might be 56 plus M equals 71. And then we can solve it. We can figure out, okay, how would we figure out this problem? Well, since we have a total and a part, we know we can find the difference between these two. And difference, like I said earlier, means subtract. So we can do 71 minus 56. And you could do that however you want. Let's see. I'll do expanded form. 70 plus 1 minus 56. I have to regroup. So this becomes an 11 and this becomes 60. 11 minus 6 is 5. 60 minus 10 is, or 60 minus 50 is 10. So we think he has 15 marbles left. And then the only last step is to go back and double check. And so we could take 56 plus 15. Let's see if we can do that, fit that somewhere. 56 plus 15, and we're hoping we get 71. So 6 plus 5 is 11. 5, 6, 7. We get 71, so woohoo! We know we got it right. So this is a lot to do, but like I said, we do this every day in our class. Important information, write our sentence, make our model, make our equation, and then solve, and then check. All right, let's do one more. A couple more, actually. All right, Emma has 28 apples. Her friend gave her 13 more. How many apples does Emma have now? All right, so important information. I would say Emma has 28 apples. She gets 13 more. And this is a point, you don't have to do this, but I would say if she's getting more, that I think we're probably adding. Then I would answer my question, how many apples does Emma have now? I would say Emma has blank apples now. Then I'm going to make my strip diagram. So, on this one, I don't think they give us a total. I think they're giving us two parts. They're giving us what she started with, and they're also giving us how much she got more. So I think we're looking for a total this time. So I'm going to put 28, and I'm going to put 13 as my parts, and I'm looking for my total, and since we're looking for apples, I'm going to use A as my variable. So we could say, let's see, I'm going to make a tricky equation. A minus 28 equals 13, or we could also do A minus 13 equals 28. Okay, but ultimately what we're doing is we're adding this 28 and 13 together. So I'm just going to use a little standard way of doing it. 28 plus 13, 8, 9, 10, 11. So I put the 1 down here and regroup. 2, 3, 4. So I think she has 41 apples now. And the way we could check that is we could take 41 and we could throw it into any one of these equations and see if it works. So let's do 41 minus 13. So here, I'll do it over here. 41 minus 13. I have to regroup a little bit. 3, 4, 5, 6, 7, 8, 9, 10, 11. So I get 8. 3 minus 1 is 2. So looky here. These parts match each other. We got it correct. All right, let's try a couple more. Ooh, decimals. Sophia has 1 8/10 pound of flour. She buys 88/100 more pounds of flour. How many pounds of flour does Sophia have now? All right, so don't let it overwhelm you. Let's just break it into parts. Useful information. So Sophia has 1.8 pounds. She gets 0 88/100 more. So when I see that, you don't have to put this, but I think it's going to be addition. So that's our important information. How many pounds does she have now? I would say Sophia has blank pounds now. All right, so again, I think they gave us two parts here. What she started with and then what she got afterwards. So I think my strip diagram is going to be, I'm going to do my total on top and my two parts on bottom. 1 8/10, 0 88/100. And since we're looking for pounds, I'm going to make my little variable P. All right, so a couple equations you could do. You could do P minus 1 8/10 would equal 88/100. We could do P minus 88/100 equals 1 8/10. And then to solve it, we could just add these two guys together. So here I'm going to write in a different color. 1 8/10 plus, don't forget to line up your decimals here and fill any empty zeros. So 0 plus 8 is 8. 8 plus 8 is 16. So we would have 6 in the tens place and regroup a whole number. So I think she has 2 68/100 pounds. And we could go back and check that by doing any of these. So let's say we did 2 68/100 pounds minus 1 8/10. I'm going to add that empty 0. 8 minus 0 is 8. Oh, need to regroup a little bit. 16 minus 8, that's a double, so I'm going to put the 8. So we get 0 88/100, and then we look over That was our other part, so we know we are correct. Woohoo! Need like a little dancing guy when we're correct. All right, let's do one more. Mia has $7.88. Notice I'm saying it a little different because it's money. She spends $6.15 on a toy. How much money does she have left? All right, let's start with just the important information. Mia has $7.88. She spends $6.15. If she's spending it, it is leaving her, so I think it's subtraction. Again, you don't have to write that there, but it helps me. How much money does Mia have left? So Mia have left, so I would say Mia has blank left. And then for our strip diagram, you got to think, do I have a total? Do I have parts? I think in this one, since we're taking money away from something, I think the 788 is going to be our total. And then we're going to take away one of our parts, which is $6.15. So we're looking for how much money, so maybe we could use M. So for equation, maybe we could do $6.15 plus the money she took away is going to give us $7.88. And so to solve this, we could subtract. So let's subtract $7. Oops. Not $7.18. $7.88 minus $6.15. Ooh, I think we may get lucky with no regrouping. 8 minus 5, 8 pennies minus 5 pennies leaves us 3 pennies. 80 cents minus 10 cents leaves me 70 cents. And then $7 minus $6 is $1. So we think she has $1.73 left. And the way we could check this is we could do this right here. $6.15 plus the money we think she has left. And we're going to see if it reaches our total. 5 plus 3 is 8. 7 plus 1 is 8. And 6 plus 1 is 7. So we got $7.88, which is what we started with. So we know we are correct. All right, so using strip diagram to solve problems, this kind of became a how do we do problem solving video, but you can see how strip diagrams can kind of help us do this. Let me show you. Probably should have done this. Whoa, all kinds of moving. Where's my eraser? There we go. Probably should have started this way. But strip diagrams for me are parts and wholes. Probably should have started. So if I have a strip diagram, I'm going to have one section that is my whole and one section that are my parts. Okay, and they can be however many parts, right? We've done 2 parts on most of our problems, but they could be any kind of parts. So these are parts. That's horrible. So we have our holes on top, parts on bottom. Some people do it the other way. They put the parts on top, the hole on bottom. Doesn't really matter, but that's what we're doing. We're comparing our holes and our parts to one another. All right, guys, let's practice in class, and I know you'll do great.